Welcome to chapter 7, and we are going to deal with qualitative information. We know that in regression models, sometimes we use variables that cannot be quantified, and so we can only describe them qualitatively. Now, such variable, we refer to them as conveyance of qualitative information. We have examples of gender, race, industry, etc. Now, one way to incorporate such variables is by creating dummy variables. And dummy variables are variables such that they can take a value of 0 or a value of 1. And these variables can appear as a dependent variable or as an independent variable. We can actually start by a single dummy independent variable where we can actually estimate a wage equation with female as a qualitative variable such that it will take a value of 1 if a person is a woman, and then it will take a value of 0 if a person is a man. So therefore, this equation, if we take this wage equation incorporating female and education, we can then determine whether the gain or loss um, to this person is a woman rather than a man, holding all other factors constant. All right, so now we can actually also alternatively interpret it as follow to say that that coefficient of rho 0, if I go back to that equation, if this coefficient, we are basically saying is the difference between the expected value of the wage of the female, the wage given that the person is a female and takes a value of 1, holding education constant, minus the expected value of the wage of the female given that um, it takes a value of 0. In other words, the mean difference between the wages of men and women um, would then be the same if there is no if there's no difference between the two. Okay, and obviously we will then have the intercept shift. All right, so now one thing that we have to be very careful of is the fact that for example, if we have a category of male and female, we cannot introduce both of them into the equation. For example, if you take this equation, if you introduce male, both male and female, you are going to fall into a dummy variable trap, and this will create a perfect collinearity because um, if say for example you would like to estimate an equation where we want to find whether the female is the one who's affected, then obviously values that takes 1, where we have values of 1, that will obviously constitute a female, so meaning all the other values that are 0 are for male, and so therefore whether you include if you include both of them, and then you're actually likely to run into the exact linear relationship that you are estimating. Now, so therefore it is advised that when you are using dummy variable, you omit one category so that you avoid this dummy variable trap. And that's why you can have two separate equations, where if you have a wage equation that is for female, then you exclude the category of men, and therefore that means that the base category in that instance will be men. And if you estimate the equation where the male category is introduced, then the base category in that case will be woman. And so you can actually estimate the two different equations. Alternatively, if you would like to include both male and female categories, then it means that you have to omit the intercept. But now we know that the interceptless models are useless in the sense that you cannot use the R-square formula because it's invalid if the regression does not contain an intercept. And secondly is that it becomes more difficult to test for the differences between the parameters, so meaning that you cannot test the difference between um, gamma 0 and rho 0. Of course, this one being the coefficient for males and the coefficient for the female. Now, so let us look at the estimated wage equation with an intercept shift. So suppose we estimate this wage equation. So obviously that means that we were estimating a wage equation for a female, meaning that in this case the female is taking the value of 1. Because remember that a qualitative variable, if it's a binary variable, so we are basically referring to it as a probability, because we are saying it takes a value of 1. So, and taking a value of 1 simply means that an event is likely to occur, because remember that the probability of 1 means that the event is likely to occur, whereas the probability of zero means that an event is not likely to occur. So like in this equation, we are basically saying we are estimating the wage equation, and we want to determine um, if assuming that the female is taking a value of 1 and holding all other factors constant, such as education, experience, and tenure. So now we are saying that if we hold all these other factors constant, it means that the woman actually earns $1.81 less per hour than men. So, and because this negative sign tells us, so if it was positive, then it would actually mean that the woman earn more. But now the fact that the sign is negative basically tells us the woman actually earning less than $1.81 per hour compared to their male counterpart. Now, are we saying, does that mean that women are discriminated against? Not necessarily, because um, being female might be correlated with other productive characteristics that have not been controlled for. So, in other words, maybe factors that are not controlled for, or characteristics that are not controlled for in this equation might actually count for why women actually earning less compared to their male counterparts. Now, what if we just estimate a wage equation with a female variable alone? We can actually see that if we do not hold other factors constant, actually women earn even less. In the end, remember that in the previous equation they earned 1.81. Now in this case they even earn way less, which is 2.51 per hour less than men. And so therefore the difference between the mean wages of men and that of women is $2.51. So what do we want to describe here? What we want to indicate here is that it can easily be tested whether differences in mean is significant. Secondly, we can also look at the wage difference between men and women, and we can also determine whether if it's large, or if no other characteristics are controlled. For example, the difference maybe is due to education, experience, or tenure. So as we have seen in this equation, because in the previous equation, other factors were hold constant, were controlled for, like education. But in this equation, nothing was controlled for, and we can actually determine whether that difference is really big. Now, okay, this is just another example, and I'm not going to go through it. Now, what if we try to use the dummy variable when the dependent variable is log y? So we can actually look at, for example, this example of, we are looking at the prices of the houses, and we are looking at um, the we want to look at whether the style of the house does have an impact on the price. And here we are looking at the dummy variable that indicates whether the house is of colonial style. So suppose now the data is collected and the equation was estimated, and here are the coefficients. So we can actually determine that by taking the derivative of price with respect to colonial, and you can actually see that that is basically 5.4%, obviously just multiplying this coefficient by 100. So what this coefficient is basically telling us that as the dummy variable for colonial style changes from 0 to 1, so for that meaning that the likelihood for an event to occur, then the house prices increases by 5.4 percentage points. Okay, so so meaning that if the house is of the colonial style, then the prices also is likely also to increase, because that's actually what the coefficient tell us. And then we can also use the dummy variables in multiple categories. Now remember that in the first instance I indicated the different variables such as gender, um, education level, or race. You can have race as one category, and you can also have another category for marital status, and so forth. So let us look at this example where we are estimating the wage equation and we are looking at the marital status. So here we have multi-category. So we have married male, married female, and single female. So what does that mean? If these are the marital status that are used, then it actually means that the single male is left out. So meaning that the single male is used as a base for this a base category for this model. So what we have been told here is that if we hold all other things fixed or constant, married men, rather married um, women will earn 19.8% less than single men, because remember that in this case the category that is left out is always used as the base category. So what we are saying here is that, so if we look at this equation, the coefficient of married female, so they are earning 19.8% less than single men. All right, so that's basically how we do the interpretation. Okay. Okay, so of course you might find some instances where the information is ordinal. So if you have ordinal information, you can also again use just dummy variables to express or to find the effect of such variable on the dependent variable. And here is just a clear example that you can just go through on your own. All right, so let us look at the last part. So what if we want to look at the interactive dummies? Remember, we have already spoken about interactive variables. Interactive variables here, it basically that it allows for different slopes. So let us take this equation. Suppose we have this wage equation where we have a female. Also in education, we have an interactive dummy of female and education. So we can actually see that the intercept for men, if we have to estimate the male equation, the intercept will be beta 0, because then female will take a value of 0. So rho, this one falls out, and here it also takes a value of 0. So this one also falls out. So then you only have beta 0. In terms of coefficient slope, since this one and that one falls out, you are only left with beta 1 education. So therefore the equation for the men will be beta 0 plus beta 1 education. But now if the male takes a value of 0, then you'll have beta 0 plus rho 0. Okay, because that's for the female takes a value of 1. And then for the slope coefficient, you'll have beta 1 plus rho 1, because the female takes a value of 1. So that's why the intercept of the woman will be that, the slope coefficient will be that. So now what we have to look out for is a hypothesis. So if the coefficient of rho 1 is equal to 0, then it means that the return to education is the same for men and women, because if that coefficient is 0, then it means that the female variable has taken a value of 1, and so therefore if the coefficient is 0, then it means that the wage or the return on education is not different for both male and female. However, if rho 0 is equal to 0 and rho 1 is equal to 0, if these two coefficients are equal to 0, then it means that the whole wage equation is also same for both men and women. Remember that the first instance we are saying if rho 1 is equal to 0, then we are basically saying the return on education on women and men is just the same. Okay, so you must just reread this and try to understand what we are saying. But however, if both of them are equal to 0, then that means that the wage equation is same for both men and women. Here is just a demonstration using a graph of how that works. All right, so if we estimate the wage equation with interaction, so we can easily determine whether the wage equation is the same for both male and female, and we can also determine whether the return on a variable is um, significant or not, or whether it's the same on male and female. Now let us look at this example. This equation is similar to just what I was demonstrating here. So it's just that now we have actual values. So we can actually see that the coefficient of the interactive term of education and female, that coefficient is 0.05. Okay, so what are we saying? We are saying that there is no evidence against the hypothesis that the return of the education is the same for men and women. Secondly, but does that mean that it's not are we saying that, and also here, if this one, however this one also has saying here, we are actually saying that it does not mean that there is no significant evidence. Are we saying that there's no significant evidence lower pay for women at the same level of education? We are saying no, because this just shows the effect of education, but this one shows it only shows the effect of average education. It doesn't show unlike here. All right, so what we are saying here that is basically what we are saying here. that because of that, so there is no evidence against the hypothesis that the return on education is the same for men and women. So it's basically the same for men and women.